Hello explorers and welcome to another video. Today we are going to talk about building TensorFlow RT or TensorRT by NVIDIA. And this video is not a tutorial. I'm not taking a dig at anyone. I'm not gonna talk badly about any company or any persons or anything like that. This is my experience with the tool and what I needed to do to get it to work. And this is that kind of a video where you say, do as I say, not as I do. And I did this because I was an early adopter and I wanted to really try the software out. I wanted to work with it myself and say, okay, I can say that this works because I have tried it. But when you are trying this, you will probably just install it and everything will just work for you. But it didn't for me. And that's because I was an early adopter. So this is just a point of view, nothing critical about anything or anyone that is involved in this project. So if we cut over to my screen here, you can see first off some statistics. We are talking about the TensorFlow project. And the TensorFlow project is 1 gigabyte of source code. It has 3,000 authors. It has the last month done 1,629 commits from 190 authors, and they have changed 70,000 lines of code and removed 70,000 lines of code. So there have been a lot of changes and they have done 6 releases. So that this RC1 that I was working on did not work out of the box on Windows is not really that. It's not something that I am really surprised about. So let's go over and talk a little bit about what I did. I took this path here. We had this branch 7.0 RC1. I checked that out with TensorFlow. I installed CUDA. I downloaded CUDNN and put all the files from that package into my CUDA directory. And I downloaded also the TensorRT and put all the files from that package into my CUDA directory as well. So I had all of those tools in one directory, namely called just CUDA, to make it simple. So if we switch over to my editor here, what I had to set in my environment path is where do I have my Visual Studio compiler, the C compiler for Visual Studio. And I also had to put the CUDA path. The other things here was put in here when I installed CUDA. So you had some CUDA version 11.5, which was the one that I was using, and also where the samples directory is and so on. So these are not some that I have added myself. This one I had to change to have e:/CUDA. And why it's called an E:/, that's my old C drive. So there is where I have all my code and so on. Then I have a bunch of paths here. We have CUDA, of course, my Python 3.9. For some reason, I daily drive the version 16 of Java. Interesting. Could have perhaps updated that. I also have a version 11 if I need some tools from there. And I have Git installed, of course, CMake. I don't think that it uses it, but if you want to try this, then couldn't hurt to have that installed. I have MSys2 installed as well, and these are the insight was put in from NVIDIA. I have the USR bin directory. It's important to have that in your path because it will search for bash and some other things from the M.2 installation. And then I had this composer vendor bin down here. I don't think that is important. That is PHP, so let's remove that. Then I had to put up a bunch of paths for my Python installation, where to find the binary, where to find the include files and the library files. These were important for me, perhaps not important for you, but setting where your temp path is and also where the test temp dir is, because that's where Bazel will import your binaries into and also do the builds into. So setting all these paths are important for me because my C drive is a fast drive, but not that large. And the build things in the TensorFlow package, you have 1 gig of source code with a lot of dependencies. So all the artifacts built up to 65 gigabytes of computer hard drive. So it just didn't fit on my C drive. So I had to put in all of these. And this needs to be or needs to be a normal Windows path, but the other ones could be in the M.2 directory. So I had to do a lot of work in order to figure out what things were needed, what I needed to set or not. I have had a lot more different environment variables that I've tried out, but wasn't needed to actually build on Windows. Then I ran the configure script. And depending on how your setup is and what kind of things it can find on your computer, it will ask you for, do you want to use CUDA, do you want to use TensorRT? It will not ask that on Windows directly if you don't modify it, because it's not supported on Windows, at least in that version. Might be in the future, but in that version it was not supported, so it didn't ask for that right off the box. But I will talk about what changes I did to get it to ask for it. And then I ran the normal build process. I said that I want the optionals, and that was to get the Arch AVX2, which was good for my environment. CUDA and TensorRT was also configured. Probably not needed as I already configured them with configure, but I put them in there anyway. And then you want to build the pip package. And when we have done that configuration, your configuration file, tf_configure Bazel RC, should look something like this. It will put in your Python binaries up here. It will say that you want to build with TensorRT, in my case modified, and also where your CUDA is installed and what capabilities your hardware has. I looked up the capabilities for my 1070 graphics card, and that was 6.1. Your graphics card will probably have something else. And then we see here that I got this arch here of AVX2, reduced huge functions, yeah, flaky and so on. Yeah. So the other things here I don't really know anything about. These up here were things that I actually configured myself. So now I can build TensorFlow. So I ran the build script and of course it failed. And here I had to struggle a lot with RC1 because I had the problem that so the LLVM could not build for me. And that's a compiler, if I'm not misremembering, and it's a dependency, another dependency outside of the TensorFlow libraries here. So it's something that is downloaded, but it is open source, so you can find it on GitHub and you can look into the source code and what to do with it. So I downloaded this LLVM project and figured out what the problem was and created a patch. How do you actually apply this patch? There is a workspace file here where you say, okay, I want to download this specific LVM version with this commit. So I downloaded the repository, put it to this commit, made the changes. And last but not least, in this file, you see that you have a patch file for this LLVM, which is macOS buildfix.patch. So I just applied some extra to that file in order to make my changes. So if we look at that, it starts off with something that has to do with the macOS build and Darwin and Arch 64 and so on. But what I wanted to change was in the utils Bazel configure Bazel file. And there I needed to take this script path and set the Windows environment e:/ to an m.sys sys2 path in order for it to even find the script that it was running here for the overlay directories. So it didn't even run if I didn't do this change. So that was a very small change. And that script took so long to run, so I actually had to change the timeout from 20 seconds and I put an hour. It's very much too long, but I think it actually took about 3 to 5 minutes with downloading and building and so on. So it took a long time to actually run. So it's not bad that I put an hour, but it's too much. And then down here, I had a problem with symlinks that was linked multiple times in this script. So it tried to create links between different directories multiple times, and that was just crashed in Windows. Will probably work just fine in Linux, but not in Windows. So I had to set a little try catch around that because I don't really care. As long as the link is there, it's fine. And then I also added some extra here just so it will not try to link the dot directories, because I had a problem with .basel, for instance. It wanted to link that up, and I didn't want it to do that. So that was what I changed in here in order to get it to build. And then I got a build of TensorFlow. But it didn't ask me about TensorRT, and I didn't get anything of TensorRT installed. And what I wanted to find was this TRT graph converted v2. That was what I wanted. But I got this convert windows instead, which have a convert windows in it, which is not implemented yet, and so on. So this file was totally useless for me. I wanted to have the other file installed, so I needed to do some changes. So if we jump over to my command prompt here, we can see what changes I made to the source code here. First off, I've looked up all these is in Linux, and just commented those out, so I will be asked for TensorFlow RT in my config script. And the same goes down here. Put that over the is in Linux. I was thinking about if I wanted this NCCL thing, but that is, if I have understood it correctly, a way to talk to external resources, and because I wanted to run this locally, I didn't need that code. And then I had to put this TF needed to 1 in a Windows environment, and also push this up here, so I will set the version for the TensorRT. Then I tried to build it, and of course it failed because I got a circlet dependency somewhere. And to solve that, I took this TF custom op library addition depths and changed it to my own version that I just added TensorRT to. And I did that a bunch of times in this TensorRT build file. And after that, I didn't get that cyclic redundancy. I will show you the changes in the code later down here, but it did build, but I got an error in this nodes convert CC, and that's because they are using some kind of lambdas, and that was not supported with my compiler for some reason. So this whole code you see here with all the pluses, the green code, is the same code as down here, but as a lambda. So I just moved it up there and then sent in some extra parameters. So this use implicit batch and also max dim mbdim, so that's the size. So I added that as well. So those two variables I needed to send into this function, and then I could do it as not a lambda. And then I had a problem again with some small little code in the segment CC, which also was lambda, where they just chose to create a lambda get nodes, which either got in nodes or out node, depending on if it was reversed. So I just switched that lambda out to this get function instead. So it will get the nodes with the reverse flag. That's the only difference here. And then I wanted to add the dependency against the libraries, of course. And this was a little bit more of a headache because they used include files, and those include files were linked to the library functions that were available, and the header file for the functions are open, so you can see those in your source directory. But all functions was not available, so I added these lines here to get for the minor version of the 8.2, this plugins file and also this env file. We will look at those. That was something that I wanted to add just to get those functions. And here we see some difference where if you are in Windows, you should put this script that is totally useless into the directory, or otherwise you want to run this. So I said, okay, every time just run that, because this TRT convert Windows, I don't want that script. And also here we have another case of if you are in Windows, don't run this TRT convert script, and I want to run it. And again, if you are on Windows, add this convert Windows, otherwise add the real one. So I commented that out. Here I believe I have this extra TensorRT that I talked about earlier. So this is the custom op library addition depths TensorRT. And the difference here is that earlier there were a similar one, but it added some library here that pretty much built the whole library of TensorFlow again and tried to build against that. And then I got this cyclic build problem that it tried to build itself, which did not work at all. And here we see the change to this Mac OS build fix patch. So that's the last one here. So we will look into this TensorFlow BSL, so you can see that change as well. Way there we have it. So this additional depths that we have here, it had, if it's Windows, add this pywrap TensorFlow import lib. And in that case, you got this dependency that went round and round and round and weren't able to build it, because this is the full TensorFlow library, which will contain this as well. So I just added my own version here so I could put that, because you need to run this additional depths in some cases where you're not building TensorRT. So if you're not having this one, it will not work for other libraries. But in TensorRT, when you build it statically, you need to skip this last part here. So that's the extra thing that I added here. And last but not least, we will look at these include files here. So here we have one example of this infer 8.2 include files. And these are built up pretty much with something that will create a function which is internal, and then it will statically link against the library. So it will load the symbols and then return a function that this function in turn could use in the stub file. So let's see, here we have this stub file. So we have the linking down here, and then it will use these function here, so load symbol and so on. So this is a way to load those functions, and then you have the include file to define what external things should be able to be loaded with this functionality. So all those changes I made and I got it to build, but I did not get as far as actually running it. So I got some last problems with linking, that it couldn't really link up. And then I was out of time, so I could not run it on Windows and actually show you that it works on Windows as well. That was one of the key points of the presentation, that it should now be working on Windows as well. But I didn't get it to work. So hopefully with the later release of TensorFlow, it will just work. Yeah, so that's what I wanted to show you. the example that I gave you in my the last week's video I showed on Linux, and with all this that I learned during this build steps, building it on Linux and getting it to work was very easy. The only thing I had to do was to change in the stub file here to add the TensorRT major version 8.2 and also add this include file, and then I was able to build TensorRT and get it to work on the Linux. So there were a lot fewer hoops to go through in order to build it on Linux. There is some more work to do before you get it to work on Windows. So this was what I wanted to cover today. I hope that you found this fascinating. Please don't try this at home. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you have any comments or suggestions, leave them down in the comment section down below. And I really hope to see you in the next video.